This is my Lab 1 report called Charge Tapes in Physics 2212. So Lab 1 uses household objects like tape to determine the forces at play in simple interactions. In this lab, we become familiar with electric force, induced charge, equilibrium, and the gravitational force. By balancing the electric force and the gravitational force, we were able to reach the goal of the lab and calculate the charge and number of electrons on a piece of tape by measuring the distance between the two pieces at equilibrium. We started by making two observations. By rubbing the tip of a pen through hair, we created a negative charge on the tip of the pen. The U-tape was then attracted to the negatively charged pen when placed near the pen. Therefore, the induced charge on the U-tape must be positive. Because the two pieces of tape repel each other and opposites repel when it comes to charge, then both pieces of tape must be positively charged. Data collection. I measured the top tape to be suspended 1.43 centimeters above the bottom tape. Using this distance calculation and the fact that the electric force, which is kq squared over the distance squared, is equal to the gravitational force, which is mg, at equilibrium, and we calculated the charge on the tape to be 6.68 times 10 to the negative 9th coulombs. Now, using this number, I found the number of deficient electrons to be 4.18 times 10 to the 10th. So, for our first question, we were asked, what if electrons had a positive charge and protons had a negative charge? What would change about the observations you made? So, if the charges of electron and protons had switched, the tapes would both have negative charges and the pen would be positively charged. However, none of our physical observations would be changed. This is because both pieces of tape would still have the same charge and they would still be repelled equally. And since the charge of the pen would still be different than the charge of the tape in sign, opposite in sign, the tape would still be attracted to the pen. Our second question we were asked in this lab was, why is it important to handle the charged tapes as little as possible, and what happens when the charged tapes come into contact with your hands or other objects? So it is important to handle these tapes with induced charge as little as possible because contact with a neutral object, your hands, will cause charge from the tape to be transferred to the hands. In this case, the tape will most likely lose charge if handled incorrectly. This will affect the charge and electron calculations in doing the lab. So in conclusion, to accomplish the goals of this lab, I applied knowledge of electric force and gravitational force, and because of the concept of equilibrium, the net force on the tape was 0. So in solving for charge, we could set the forces equal to each other and get our final calculations. On the left is a picture of my GlowScript code, and on the right is the image that the GlowScript code produced.